Alright, so we're going to apply Ohm's law to series circuits. First thing we need to do is add our triangle. So we got V over I times R. You know this is volts. Symbol is V. Resistance, the symbol is omega. And this will be amps. So we got volts, resistance, and amps. Ohms. Remember, this is in ohms. Okay, this is, excuse me. This is amps. And this V is for volts. Okay. Next, we need some rules for series circuits. So, rules for series circuits. Okay, first rule is the total resistance is equal to R1 plus R2 plus R3 and so forth. Okay, the total amps of current, okay, would be I1 is equal to I2 is equal to I3 and so on, which means once you calculate the total amps, it's the same throughout the entire circuit. Okay, then voltage, total voltage would be V1 plus V2 plus V3 or so forth. Or the reciprocal. So if you have, like, say 3 parts on a circuit and you have 2 of them, then the third part would be the reciprocal of the first 2. So if you don't recall, here, let me just add a circuit. Okay. This would be the positive side. It's bigger. This would be the negative side. It is smaller. Okay. So this would be 60 volts at this circuit. Okay, I'm just making this up. So 60 volt battery at this circuit. I'm going to make 3 resistors on this series circuit. I'm going to put one here. This would be resistor 1. This is resistor 2. This is resistor 3. And let's give this one a value of 17 ohms. This one a value of 12 ohms. And this one a value of 11 ohms. Okay, so I'm just setting this up for you all to, use this technique going forward when you calculate for any series circuit. I'm going to call you back, son. All right, so my son just called. So, all right, so let's set this up. This is how I want you to set it up. When you see this, you need to have your rules. You need to have your Ohm's law triangle. And now you need to do a data table. And in your data table, I want you to establish total resistance, total current, and total volts. And depending on how many parts you have in your circuit, we have 3 parts, so I'm going to go resistance 1, resistance 2, resistance 3. Current 1, current 2, and current 3. Volts 1, volts 2, and volts 3. Those mean that at each part, so this would be part 1, this would be part 2, this would be part 3. Okay? Alright, so now we got to put in, let's put in what our givens are. So first of all, we already have the total voltage right here. Okay, so total voltage would be 60 V. Alright, we kind of already have our total resistance too, because the rule states that R1 plus R2 plus R3 equals total resistance. So 17 plus 12 plus 11 would go here, 40. We can put 17 here, we can put 12 here, and we can put 11 here. Okay, so 17 plus 12 is 29, plus 1 is 30, plus 10 is 40. So 40, okay? Now, we use Ohm's law. We can already calculate the total current here. Because if we take from our triangle, our rules, total voltage divided by total resistance will give us our current. So if we're looking for current, you cover up the I. Cover up the I, okay? When you cover up the I, you do the rest. And that's volts divided by resistance. So volts over R would be 1.5 amps. All right, so now we know the amps of the entire circuit, because the rule here states if current 1 or total current is equal to current 1, 2, and 3, then that means all of these would be 1.5. Okay. Now we use our triangle finally to find the voltage. At each one of the parts, we have what's called a voltage drop. Oops, excuse me. A voltage drop. Because this is a series circuit, if I had 3 light bulbs sharing this one series circuit, all 3 light bulbs would share the 60 volts, but they wouldn't have the same voltage at each light bulb because they're sharing it. So let's calculate. I need to bring a calculator up. Oh, I don't have one. Here, I'm just going to use one on the side. Okay. Oops, sorry about that. I'm going to use one on the side. So I need to calculate for the voltage. How do we get V? If we cover V up here and do the rest, would be I times R. Okay, so we're going to do I times R for each one of these to find each voltage. So 17 times 1.5 is 25 point, oops, sorry, 25.5 V. Then we do 12 times 1.5 and we get 18 V here. And finally 11 times 1.5 and we get 16.5 volts. I want to check to see if this is right. According to our rules, if we add up V1 plus V2 plus V3, we should get the total voltage. Total voltage was 60 volts. Let's see if this adds up. 16.5 plus 18 plus 25.5 equals 60. We are correct and we are done. We have all of our resistance in each part, all of our current in each part, and our voltage at each part. Okay? Now let's do a practice. I'm going to do a practice here with another, let's say, I think I have something open already with another current, another circuit rather, here in Safari. Let me see. Actually, it's in my drive. I already have it open in my drive. So let me pull that up in my Google Drive where we can practice. All right, here we got it. Now, in this practice, they don't ask for all of the variables at each part, okay? Also, here, let me copy this. Let me copy this and bring this over to Notability. All right, I'm going to copy some more rules to put in Notability, all right, for you all to follow. Okay, you need these extra rules, or not extra rules, they're just rules for series circuits so that you understand what's going on. So here are rules that we already had here, okay? I'm going to add some more rules down here, and I'm going to do this by paste. So text, I want to paste. Oh, I don't want them there. Undo. There we go. All right, I want to hear. All right, so let me get my keyboard together. That is a bullet point. This is a bullet point, and this is also a bullet point. Okay, and this would be total voltage. Total voltage. All right, so these are the rules too. The current in every part of the circuit will stay the same. Don't add up. They will stay the same. Okay. Then you have the voltage supplied by the battery is the total voltage of the entire circuit, and the voltage drops across each resistor will be the same, or they will add up to the total voltage. Okay. Then you have the total. To calculate the total resistance, you add them up or you use reciprocals. All right. So let me pull those other examples back up out my drive and do one more example. Okay, so I'm gonna do a series circuit with just 2 drops. So I'm gonna use 2 drops. It is a 90 volt battery. Drop 1 is 10 ohms. Drop 2 is 20 ohms, and that is all we have. Okay, all right, let me draw that. Okay, let me get rid of that and draw it here in Notability for you. All right, here we go. So I'm going to draw my, let's use purple. Okay, I'm going to draw my circuit. Okay, and it's got a drop here with a resistor. Resistor here, resistor 1 we said was 10 ohms. Resistor 2 is 20 ohms. And 90 volt battery. So let's put our RT here equals, and R1 equals, and R2 equals. Let's put current total here equals current 1 and current 2. And let's do volts here. Volts total, volts 1, volts 2. All right, well, let's put in our givens. We have total voltage right here, 90 volts. We know the resistance total because remember we said R1 plus R2 plus R3 and etc. So R1 here is equal to 10, R2 here is equal to 20, which gives us a total of 30 ohms. R1 is 10 ohms and R2 is 20 ohms. So we get 30 ohms here. 90 volts divided by 30 ohms would give us 3 amps across the entire circuit. So we got 3 amps here, 3 amps here, 3 amps here. All right, 10 times 3 right here, according to Ohm's law, would be 10 times 3. Voltage 1 would be 30 volts. Then we have 20 times 3 here, which is 60 volts. Let's check to see if we are correct. If we have 30 and 60 equals 90. Yes, we are done. So we've solved everything that we needed to solve. We solved here for current. We solved here for total resistance. We solved here for voltage 1, voltage 2. Okay, so going forward, this is what you would need to do series circuits, and that this sheet that I just showed you in Notability, this is what you would need to do. Okay, if you have any questions, post them in Google Classroom. Thank you.